Hello guys, in this assignment you need to figure out who killed Bill. Now it turns out that in order for this shot to be pulled off, um, the bullet had to have an average speed of at least 400 meters per second and an acceleration of 90 meters per second square. Now here we have data for 4 possible suspects and we have the information of distance and time for their bullets. So what we need to figure out is which bullet is going to be traveling at least with a speed of 400 meters per second and with an acceleration of 90 meters per second square. Now the first thing that I asked you guys to do was to make a graph. So you're going to use a spreadsheet for that or whatever you feel more comfortable using. And what it says right here is that you can copy and paste the yellow area. So I'm going to do that with you guys here. So the yellow area, I'm highlighting it. I'm going to say do Control C and then go to my spreadsheet and do Control V. Still highlighted. Now my screen is a little small, but you can see, you can look for this small square with some bars, or you could just go to Insert Chart. It's the same symbol. If you do that, automatically it should give you the graph. If it doesn't, then just look for chart type, line chart. But it usually gives you automatically the graph. So there it is, we have the graph. We can modify the title here. Ideally, I ask you guys to fix the y-axis too. So you could do that in the options. But even if we're not doing that, we're going to pay attention to the graph. So you're going to, I'm highlighting again the graph, I'm putting Control C, I'm going to put Control V now here, I'm going to paste it in my document. And I apologize, let's see, let's try that again. So I'm going to go here, Control C, Control C, and let's try that again here where it says enter picture, Control V. And I don't really want to link it, so let's just put paste. All right, and there it is. There's my graph. Now, the nice thing about this chart is that it gives us something familiar to work with. We at least saw the shape of the position versus time graphs, and we see some here. Okay, question 1, or the first thing that we needed to do is there. Okay, and I had one prepared there, so I'm just going to erase it. Now the next step is says use the slopes of each graph to calculate the average speed of each gun. Now that is a possibility, but I'm asking you also to remember that the average speed is the total distance over the total time. So that's all that you need to do. So that's what we're going to do. We're going to look at the total distance over the total time. So we could do it by looking at the graph or looking at the data table. So let's look at the data table actually. So for curly, it's here is the blue, and we could see that curly cover this distance over 5 seconds. Now it's a little hard to read from here, and if that's the case for you too, just come back to the table. So the distance at 5 seconds was 2,500 meters. So let's go ahead and use that. 2,500 meters divided by the time. So I'm going to go ahead and put that for curly here. So the velocity, I wanted for you guys to do this in the notebook so that you don't need to be figuring out the formatting of these. But anyway, let's go back, and again it's 2,500, that's meters per second, that is 5 seconds. Okay, and from there you can figure out curly's speed. And this is going to be, so 5, 0, 0. Okay, and that is meters per second because it's the speed. So we talk about this, the slopes of the graph of a distance versus time graph represents the velocity. So nothing new, we're just adding numbers. Now for Drew, we're going to do the same thing. Drew's bullet covered a distance of 1,500 in 5 seconds. So that's what I'm going to put right here. So Drew's velocity is going to be, and again, 1,500 meters. And I'm going to divide it by the time, which is 5 seconds. So remember, I'm using this from this equation right here. Average speed is distance over time. Okay, that's all that I'm doing. And I'll continue doing the same thing for Mo and Hersey. Now, from these values that you guys are getting here, you need to figure out which one is the possible bullet that is going to be belong to the person that committed the crime. So remember the parameters. It has to have at least 400 meters per second. So that means 400 meters per second or higher. If any bullet is lower than that, that means that that's not our suspect and we can eliminate that suspect. Okay, so you guys can figure this one out once you have the data. Then after that, it's asking you to describe whether the bullets are speeding up, slowing down, or moving at a constant speed. This is where the graph comes in place. Now for Curly here, I put already that it's a constant speed. Now why? If you look at the graph, the blue line is a straight line. And we said that in a position versus time graph, if we have a straight line, that means that the object's moving at a constant speed. You guys could go back in your notes and check that. Now let's look at Drew. Drew's graph is the red one. Now check what's happening here. Now you don't have a straight line anymore. That means that the speed must be changing. Let's now see if it's speeding up or slowing down. So what I'm going to do here is I'm going to pay attention to the slopes. So let's say that that's my first slope, and then I'm going to follow the other, I'm going to trace the other side of the line. I kind of mess up with that one. Let me see if I can erase it. Okay, let me erase this one because what I wanted to do was just follow what the red line was doing. Okay, so here is the other slope right there. And then we have another line right there, so I'm going to make another one there. And then we have another line right there. Okay, so notice that the slopes are changing. First, it's not quite steep. Then it's a little bit steeper. Then it starts declining its steepness, and it's less steep. So it seems that in the beginning, it was increasing in speed. So it was speeding up, but then it was slowing down. So that's what I'm going to put for Drew. Speeding up and then slows down. And now we're going to do the same thing for Mo. I'm going to erase what I just did there. And now let's look at Mo. And Mo's graph is going to be the orange one. So something similar happens with Mo. We start with a certain slope. I'm covering this first chunk. Actually, this one is a little bit more consistent. Actually, maybe up until there. That's the first slope. But then the line changes a little bit, and now it gets a little steeper. And then it reduces in steepness. So it's doing something similar. It's increasing in velocity, but then it decreases. So it's also speeding up. So this one is the same as the previous one. I'm gonna just put those two signs. It's speeding up and then slows down. And then you're gonna look at Hersey. Hersey is the green one. Take a look at the slope. What is it doing? It's kind of a curve. It's not a straight line, so pay attention to that. Okay. Then lastly, and this is probably where some of you guys are having some issues, is finding the acceleration, because that's the last parameter. So if you notice for Curly, I put 0 here because we observed that in the previous part. Let's erase this so that we don't get confused. But if we look at Curly's graph is the blue one. That's a straight line. We said that in a position versus time graph, if the line's straight, that means that the velocity is constant. That's what we have right here. And if the velocity is constant, it's not changing at all, then it's not accelerating. So the acceleration is 0. You don't even need to put anything into the equation. And automatically, that's a hint for you, we should say that this eliminates Curly as our suspect, because it says that the minimum acceleration over here has to be 90 meters per second squared. So Curly is eliminated from the list. Now with Drew, let's just follow what we have here. We know that Drew is speeding up and then slowing down, so it must have some acceleration. We're going to find the average. So for acceleration, we're going to look at the final speed minus the initial speed. Now, this speed that we calculated over here, that's going to be our final speed because that was at the end. So just keep in mind that right here. So for Drew, let's go ahead and do this. So 300. Okay, so for Drew, for example, the speed was 300 meters per second. So that's going to be our acceleration right here. Our final speed is 300 meters per second. And our initial speed, they all started from 0. It wasn't moving. So we're going to do minus 0. The initial speed is 0. Divided by the time. And the time for all of them is 5 seconds. Sorry guys, I'm getting it from the data table. 5 seconds. Okay. 5 seconds. So when we do this calculation, that would be 300 divided by 5. So that would give us 60 meters per second squared. And I'll just modify that for you so that it is not confusing. Okay, there it is. We're going to do exactly the same thing for Mo. Whichever velocity you found over here, that's going to be your final velocity to put right here. So you're going to have acceleration equals the final velocity that you find up there minus 0 still because they all started with a speed of 0 and divided by 5. Okay, and you'll do the same thing for Hersey. 5 seconds. And now once you find these accelerations, you'll be ready to figure out who was the one that committed the crime, and you have all the evidence to show that that's the person that is guilty. So I hope this helps, and if you have any more questions, contact me. All right, thank you guys.